Okay, so today we're going to finish up chapter 6. This will be day 2 of 6-4. The only thing we're going to graph today is going to be the tangent function. You will not be responsible for graphing the cotangent function in Algebra 2. You will be graphing the cotangent function in pre-calculus. All right, so before we begin, let's go ahead and just review what we know about tangent. So again, way back in geometry, remember you learned that tangent of whatever angle it is was always opposite over adjacent. Or what we've seen with the unit circle, y over x. Now remember we also saw the values that these different trig functions could take on. Remember sine and cosine was always a fraction. It had to be between 1 and -1. But tangent, we saw that it could be any number. There's no restrictions. It could be any number, all real numbers. Now, remember our little axis here. And remember that 0 and 2 pi are located over here. This is the pi over 2. This is the pi. And this was 3 pi over 2. And then over here are the ordered pairs for it. So this is 1, 0. This would be 0, 1. This is -1, 0. And over here, 0, -1. So if I went and I did tangent on these really quickly, so like for example, if I did tangent of 0 or tangent of 2 pi, remember it's y over x. So if I use this order pair, oops, I don't want to cross it off. If I use this order pair for these guys and I do y over x, you can see it's 0 over 1, which is 0. Same on both. Then if I did tangent of pi over 2, I would use this order pair. And then I could get tangent, just to show you how we're going to get this graph. Tangent of pi over 2, y over x. Notice I get a 0 in the denominator, so it's undefined at pi over 2. Same thing for the 3 pi over 2. If I jump down here and do this bottom one, 3 pi over 2, it's also undefined down here because I would do -1 over 0, which is also undefined. However, at tangent of pi, this one's also going to be 0. So if you did that, that's over here, uses this order pair. So y over x is 1 over -1, which is 0. So just to show you how this all links together. Okay, so now what we're going to do on tangent when we graph it, all of the other trig functions, the period length for those was 2 pi. The period for tangent is just going to be a full cycle. We're going to be able to complete it in pi. So, remember when we were trying to find our points, we had to break it into 4 sections or 4 quarters. So over here, I'm going to break this and show 4 separations. The last one's going to be pi. And then remember to get the values on the other ones. I take pi, multiply it by 1/4, 1/2, and 3/4. So here I'm going to get pi over 4, pi over 2, 3 pi over 4. So I can go ahead and label those points. And it's going to be the same thing on the left side of the y-axis. They're just going to be negative. So pi over 4. Let me make that a little neater. Pi over 4. Pi over 2. 3 pi over 4. Over here, same thing, but negative.
Pardon the interruption. Victoria Cordona, please report to Student Services. Victoria Cordona.
All right, now, to make this a little bit simpler, what I'm going to do is I'm going to draw a rectangle and sort of almost like your graphing calculator. I'm going to make it like a window of where I want to see my tangent graphed. So I'm going to draw a green rectangle around the window of where my graph is going to be located. So again, remember the period goes from negative pi to positive pi. So this is going to be where I actually want to draw the graph of tangent. Because again, I only want to see two periods. So I'm going to show from 0 to pi and then from negative pi to 0. Now, remember, it's got some asymptotes in here. So remember these calculations I did over here? All the places where it's undefined, that's where I'm going to draw in my vertical asymptote. Now, the 3 pi over 2 is out of my window, so I don't need to show that asymptote. So the easiest way to do this, instead of having to do these calculations, is if you figure out the length of your cycle and you draw your box around it, it's going to be the second point or the halfway point of your box. So I have a vertical asymptote at this point of pi over 2. So it's always going to be the one that gets multiplied by 1/2. That's where your vertical asymptote is going to occur. Now, the middle section that's going to be in between these two asymptotes is going to be the shape that the rest of the graph takes on. So if you remember from the calculation over here that when you plug in and you find tangent of 0, it's 0. So I'm going to graph that order pair, 0, 0. Does anybody know what the tangent of pi over 4 is? Okay, it's 1 and negative 1, right? So when it's tangent of pi over 4, it's 1, because that's your 45. Remember I told everybody to memorize tangent of 45 is 1, and tangent of the negative 45 is negative 1. So I'm going to graph that. So pi over 4 is 1, and negative pi over 4 is negative 1. So let me show that this is going up to 1. Okay, so now I'm going to make my graph. Again, the asymptotes are going to keep my graph in line here. So I'm going to go up. Sort of looks like this x cubed graph. And then it skims down and it goes to infinity. So this is your tangent graph. Now again, remember also at pi, it also equals 0 and negative pi. So these other points that are over here on the edges are going to take on the same shape. Now this one, the upswing here, is outside of my graph, so I'm going to draw it in green. But this side is still in there, so I'm going to draw it in red. And then over here, this would be in my green box, but this is out. So if you wanted to show that it takes on the same shape. So I really didn't need to show the green outside. My graph of the tangent function that's within the period is just the red. So for the test, if you want to bring a highlighter and then just highlight your final answer, you can. I also have colored pencils you can use. All right, this is just a screenshot of the textbook. And here we go. We've got, not only are we changing the cycle length or the period length, we're also adding in an amplitude. Okay, so the 2 is our amplitude. Our amp, and that's how high it's going to go. So I could put that on here now. It's going to go up to 2 and down to negative 2. Now, right here, the number in front of x, I'm going to take my period, which is pi normally, and I divide it by that. Remember, it's the period divided by b. That's our b. So I'm dividing it by 4. So now my cycle length, or I can complete one full cycle in pi over 4. I need to figure out these 4 points. 1, 2, 3, 4. Same thing over here. And remember, you take this cycle length, pi over 4, multiply it by 1/4, multiply it by 1/2. Again, remember the 1/2 multiplication answer, that's your asymptote. It's the halfway point. And then the pi over 4 times 3/4. So this becomes pi over 16, pi over 8, 3 pi over 16. So I could go ahead and put my box around this if you want first, or you can label those points, either way. But this is my window. This is the only thing I'm interested in seeing graphed, what's in this green box. So again, pi over 16 is here. Then pi over 8. Then the 3 pi over 16. And then lastly, the pi over 4. And then the same thing on the other side. So negative pi over 16. Negative pi over 8. Negative 3 pi over 16. And then negative pi over 4. Again, draw your asymptote in at the midway point of your box here. So at the pi over 8. And now we're going to go ahead and put our points in here. So 0, 0, because tangent is 0, 0. Then at the pi over 16, I'm going to make that go up to the amplitude of 2. So what am I on here? And then here. And then down here to the negative 2. Again, it's going to go to infinity. And then down. And then we're going to take on the same shape for the point from pi over 4. So pi over 4, again, remember pi over 4 was 1, but when I times pi over 4 by 4, it just becomes pi, which is 0. So here, this would go out of, well, this would be inside here. But for the other side of it, it's outside. So I'll do it in green. This one's outside. And this is inside. And it goes up towards the asymptote to infinity. So that would be where the cycle or the period was changed. And it also had an amplitude of 2. So this one's going 4 times as fast. Now we're going to go half as fast, so we're going to go slower on the next example. You're pretty good on this one? Okay, so for the next one, this one's also got an amplitude, but this time it's a negative 3. So this one, when I go to graph it, it's going to be like a reflection. So this is my amplitude. And again, to get my new cycle length or my new period length, I'm taking pi, I'm dividing it by the 1/2, keep change flip, it becomes 2 pi. So now again, to get these 4 points, 1, 2, 3, 4, I'm going to take 2 pi and I'm going to break it into quarters. Multiply it by 1/4, 1/2. So let's go ahead and try that. So 2 pi times 1/4 gives me, simplify, pi over 2. Two pi times 1/2 gives me pi. 2 pi times 3/4 gives me 3 pi over 2. And then the last point is going to be the 2 pi. Let me see if I can fix this a little neater. So pi, 3 pi over 2, and then 2 pi. And then over here, negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So let me go ahead and put my box around it, and then I'll find my asymptote, which is halfway. So let's draw the green box. Draw the box, and it's just not wanting to work today. Here's the box. So this is the only place I'm interested in seeing my tangent graph. Again, I'm going to draw my asymptote. It's going to be at the halfway point, which was the pi. And now again, I'm going to graph my points. This also had an amplitude of -3, so let me add that in. So 1, 1, 2, 3. 1, 2, 3. So I would normally go up to +3, but because it's a -3, I'm going to go and put my first point over here at the pi over 2 at -3, the 0, and the negative pi over 2 will be up at +3. So this almost looks like the negative x cubed graph once I connect the points. So again, my middle is here. Again, it goes to infinity. And then the 2 pieces on the side are going to take on the same shape. So again, if I were to continue this, it would be going up. This would be outside of the box. Over here, it would go in. And this one would be out. So again, you will not have to graph the cotangent. You will not have to shift it. We're only going to change the speed of it. So this one is going slower. It's going half as fast. So for the test, be able to graph the sine, cosine, cosecant, secant, and tangent, and be able to apply speed changes and shifts up and down and left and right. Your homework is these 4 questions. Again, just what we did today, just tangent. And then tomorrow we're going to work on the review in class. Now I know some of you have started it, which is probably a good idea, because you will not be able to finish the entire review in class tomorrow. It's long. So if you want to start on some of it tonight, you can, and then use your time wisely tomorrow and ask questions. Use the class period to get any questions you may have, about any confusion. I'll probably review the calculator portion with you too before we start working on the review.